Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on maximum power transfer theorem and its maximum power derivation and its related problems. Now here, so what is the statement? When load resistance equals to source resistance, then maximum power transfer to the load in a linear bilateral network. That is the theorem statement. So here maximum power transfer theorem states that linear bilateral network, maximum power is delivered to the load when load resistance equals to source resistance. That means internal resistance of source. Now here if you see the diagram here over here, this is the actual given circuit. This circuit is replaced by single equivalent circuit. Every circuit has its own internal resistance and its source voltage. So that is it looks like a Thevenin's equivalent circuit, and this is the load resistance. Vs is the source resistance and Rs is the source. Vs is the source voltage, Rs is the source resistance, and RL is the load resistance. When load resistance equals to source resistance, then maximum power transfer to the load. When RL equals to Rs here, when load resistance equals to source resistance, and then here power will be maximum power transfer to the load. Remaining all other resistance cases, if it is a variable, if you change the load resistance, the maximum power transfer to the load at source resistance condition of load resistance. Now if you see the derivation here, maximum power derivation, so that is most important in the examination point of view. First, so the derivation, actual what is power formula, I square r or v square by r or v equal v into I. So we see that formula first. Here what about I? Here current flowing through this one. So now here when load resistance equals to source resistance, then maximum power transfer to the load. Here IL equals Vs by RL plus Rs. As already we discussed in the Thevenin's theorem, this formula, this IL equals to current flowing through this IL equals to load resistance equals to this total voltage divided by Rs plus RL. Now here Vs by Rs, RL plus Rs. Now here power equals to, what are the formulas? P equals V into I and I square R or V square by R. This we know this formula. Power equals product of voltage and current, or V equals IR, that means I square R, and I equals to V by R, that means V square by R. Now here power delivered to the load, here PL equals to VL into IL, that equals to IL square R. This IL, if we know the current value, then we can write the power formula, that PL equals to IL square into RL, this load resistance, this IL square into RL. From this formula you can write this formula. Now here, now substitute this IL equals to, here IL equals to this one, this IL substitute here. Now here PIL square, so PL equals to power delivered equals to Vs square divided by RL plus Rs square into RL. Just this IL equals to this one. So now this is IL. Now here, now to get the maximum power condition, so first derive with respect to the RL. So this power is derived with respect to the load. This PL is derived to get here P maximum here. So derive with respect to the RL. This condition is most important for maximum, to get maximum power condition to when load resistance equals to source resistance. So derive the load power delivered to the load with respect to the RL. So this condition, that equals to 0, dou PL divided by dPL divided by derivative of DRL equals to 0. Now substitute this PL equals to this PL equals to here. Now here PL equals to Vs square by Vs square divided by RL plus Rs whole square into RL divided by DRL. How? Now here we have U by V format, du by dV format, this one. So U by V formula, d by derivative of U by V formula. Now here for that case, now here V square. So here this one is, actually this one is Vs square into RL divided by Rs plus RL whole square. This is the V and this one is the U. Now here V is a whole square, V as a square divided by V as a square. So U V square, U by V square. Now here this one. So here V into du minus U into dV. This is the formula. Now here V square. So RL plus RS square into square, that means 4, and this is V RL plus RS square. This one. Next Vs square RL, Vs square RL Vs square RL derivation is d by drl. Now this r drl gets cancelled. We have only Vs square. Now here we have only Vs square. If you derive this one, you will get Vs square only this one, and minus 2 in minus Rs plus this is U, and RL plus Rs whole square derivative d by drl is equals to 2 into RL plus Rs into drl divided by drs. That equals to 2 into RL. This one equals to. Now here this equals to 0. Now here RL plus RS into RS. If you simplify this, if in the denominator part LHS side, if it is goes to the RHS side, this term is 0. Now here if you take the common RL plus RS, and here you will get RS minus 2RL, that equals to RS minus RL. This is RS minus RL. Now here this RS equals to RL. RS equals to minus RL. Our resistance never be the negative. Now RS equals to RL. This is the condition maximum. When load resistance equals to source resistance, then here maximum power transfer to the load. This is the condition. So the maximum power condition is the RL equals to RS. This is the condition. Now here, what is the maximum power? So which amount of the power? So that power formula equals to PL equals to I square R IL square RL, and now PL equals to, this is the IL. So Vs by RL plus RS whole square into RL. Now here that. So now Vs square by RL plus RL. This R, when load resistance equals to source resistance, this one and this one is same. Rs is equal to RL. Now here substitute in this, you will get PL, this one equals to power, maximum power delivered to the load equals Vs square by 4RL. Here this is most important, that maximum power transferred to the load, that maximum power equals to Vs square by 4RL when load resistance equals to internal resistance of the source resistance. This is the statement. The maximum power transfer theorem states that in a linear bilateral network, maximum power transfer to the load this much when load resistance equals to source resistance in a linear bilateral network. Now let us take one problem. Now here if you see the graph first, this is the graph. When here is the P maximum, this if you take the this is a variable resistance, so change the resistance value. Suppose this is 1000 ohms, this is 5 volts, and here change the resistance value. Now here this load resistance is variable, here I'm changing, and power delivered to the load is, if you increase the resistance maximum, increasing maximum, and when load resistance equals to source resistance, here power is maximum, so that power equals to Vs square by 4RL, and decreasing above greater than 1000, and the power will be decreases. Even if you increase the resistance value, the power will be decreases. Only maximum power is at load resistance equals to source resistance. This is the condition. Now let us take one problem. So find the value of RL for a given network. Below that power is maximum, and also find the maximum power through load resistance by RL by maximum power transfer theorem. So now if you see the diagram here, circuit, in the circuit 15 volts, 82 ohms, 150 ohms and 47 ohms and RL. Here RL, you are supposed to calculate the RL value when for maximum power transfer to the load. Find the value of RL. Here this RL value in a given network below. Power is maximum. Power is here. Power should be maximum. So first this circuit convert into the Thevenin's equivalent circuit. Means that Thevenin's equivalent circuit is voltage source in series with resistors and in connected across the load terminal. Here RL you need to determine. So when RL, how we can calculate the RL value when load resistance equals to RS equals to RL, then maximum power transfer to the load. So first RS value can be calculated. So from the Thevenin's Thevenin's resistance steps. So first to calculate the VTH, VS and RS. So first if you know the RS and VS, then we can calculate the maximum power also. Here maximum power also we need formula, maximum power equals to VS square by 4 RL. So now if you first calculate the RL and VS, then only you can determine the maximum power and RL. First I am determining the VS value. So first VS, to determine the VS. So first if you apply KVL here, if you apply mesh analysis for this circuit. So first one, and so first VS can be calculated. VS can be calculated. First this VS can be calculated first here. This is the load resistance and this is 15 volts. 82, 47, 150 and this is RL. So first remove the load resistance from a given circuit and place N minus, this is VOC. Calculate the open circuit. That open circuit voltage is known as the VS. Now here, so here possible number of meshes, here 1 and 2. Here mesh 1 current is I1 and mesh 2 current is I2 in clockwise direction. Now here I2 current equals to 0 because it is a open circuit, because here we open the load, remove the load resistance and calculate the open circuit voltage, and that open circuit voltage known as VS. Here this is the VS. Now here if you apply KVL in the mesh 1, 15 minus 82 I1 150 I2 minus I1 minus I2 is equals to 0. Algebraic sum of total voltages in a loop equals to 0. Now here second, if you simplify this one, what will be the equation? 232 I1 82 plus 150 I1 minus 150 I2 is equal to 15. This is the first equation, equation number 1. And second equation, so 150 I2 minus I1, 150 I2 minus I1, 47 I2 plus VOC is equal to 0. Now here algebraic sum of total voltages equals 0 according to the KVL. Now here 1 minus 150 I1 and 150 plus 47 I2 and plus VOC. Here I2 equals to 0 and this I2 equals to 0 and here I2 equals 0. From this you can equation number 1 and 2. If you solve these two equations, you will get I1 and VOC. Now here I1 equals to 0.046646 and I2 equals to 9.6 volts. Now here VOC is known as the VS, source voltage, and here this is the 9.6 here. Now 9.6 volts, this one. Now we got the VS value. What about RL value? RL value, RS value. First calculate the RS value. RS equals to find out the RS value. Now here to find out the RS value, first remove the load resistance. What are the steps to calculate the Thevenin's equivalent resistance? Here this is the voltage source and this is the load resistance RL 82, 47 and 150 and 15 volts. Now here's what are the steps. First remove the load resistance from a given circuit and remove the load resistance from a given circuit, and this voltage source is replaced by short circuit and current source is replaced by open circuit. Calculate the are equivalent. Here 82 and 150 are connected in parallel and again in series with 47. Here if you see here RS equals to 82 plus 150 are connected in parallel and 46. Now here 82 into 152 resistors are connected in parallel R1 and R2. In that case R1 and R2, R1 into R2 divided by R1 plus R2. That is the condition, R1 into R2 divided by R1 plus R2. Next plus series connection, add, that is plus. This is plus indicates the series connection. Now if you see what will be the value of source resistance, that is this is 100.048 ohms. Now this is the 100.048. Now according to the maximum power transfer theorem statement, here the find out the RL value for a given network. The maximum power. So when it will be maximum power here, when load resistance equals to RL equals to RS, here is the maximum. So here this RL value equals to 100.048 ohms. Now what is the maximum power formula? Maximum power formula equals to Vs square by 4 RL. So now here Vs square by 4 RL. This is the maximum power. PL maximum power equals to here Vs square by 4 RL. So Vs square equals to 9.6 into whole square divided by next 4 into 100.048. This value equals to 0.23 watts here. Now second question. Find the RL value for the below circuit and the power is highest. Power is highest is the maximum as well, and find the highest power through RL using the theorem maximum power transfer theorem. Same formula, same thing, you need to determine RL and maximum power. So first this is the circuit and the circuit is replaced by Thevenin's equivalent circuit. That Thevenin's equivalent circuit consists of voltage source in series with the resistance connected across the load terminal. So first to calculate this RL value, first determine the RS and Vs. RS is the always RL according to the maximum power transfer theorem statement when it is the maximum power transfer to the load. Now here first calculate the Vs and RS, then you will get the P maximum equals to Vs square by 4 RL. Now this is the maximum power formula and RS equals to RL. This is the maximum power condition. So first calculation of Vs. Here calculation of Vs means here. So first what are the steps here? 4, 2, 5. This is 20 RL. So to calculate the Vs source voltage, and first remove the load resistance from a given circuit and calculate the open circuit voltage. Here 1 and 2, this is I1 and this is I2, and I2 current equals to 0 here. I1 and I2 in clockwise direction, I2 current equals to 0 as discussed in the previous problem. I2 current is 0 because of open circuit at this condition. Now if you apply KVL in the mesh 1, 20 minus 4I1 minus 5I1 minus I2, and this one equals to minus 4 plus 5, 9I1 minus 5I2 is equals to 20. This is equation number 1, and that second equation 5 into I2 minus I1, and this is not 4, this is 2, and 2I2 plus VOC equals to 0. Now the simplified equation 5I1 plus 7I2 plus VOC equals to 0. Here this I2 equals to 0, this I2 equals 0, and this I2 equals to 0 because of open circuit at load terminals. Now solve these two equations, you will get I1 and VOC. I1 equals to 2.22 and I2 VOC equals to 11.1. Now here VOC means the Vs, this is the 11.1 ohms, and now here Vs equals to 11.1 volts. Next, find the RS value. RS means First, to calculate the RS, first remove the load resistance from a given circuit. First, this is the circuit RL 425 and this is 20 volts. So first remove the load resistance from a given circuit. Voltage source is replaced by short circuit and calculate the R equivalent. That R equivalent is known as the RS, that is Thevenin's equivalent circuit. Now here 4 into 5, 4 and 5 are connected in parallel, again in series with now. Here RS equals 4 into these two are connected in parallel and again in series connection with the 2 ohms resistor. The simplification of that is 4.22. Now this equals to 4.22 ohms. Now here we got RS and VS and RL value. RL value equals to same thing. RS equals to RL, that equals to 4.22. So now here RL equals to 4.22 for the circuit below this circuit, that the power is highest when it is a maximum power transfer to the load, that RL value equals to 4.22 ohms. So now find out the highest power, maximum power through this RL and then maximum power transfer to the load. Here PRL equals to, that equals formula Vs square by 4RL. Vs square means 11.1 whole square divided by now 4 into 4.22, that equals to 7.43. This one watts, this one 7.43. Now here third question, assuming the maximum power transfer from the source to load, find the value of this amount of power in the circuit. Now here from the source to load, first convert this circuit into the Thevenin's equivalent circuit. Here this, find out this RL value, and find this maximum power also, P maximum also it determined, that equals to Vs square upon 4RL. Now this one. Now here first determine Vs and RS. First, how we will calculate the Vs? Vs first, here this is the circuit. This one 28 volts and 7 volts 41 RL. And remove the load resistance from a given circuit. Calculate this open circuit voltage plus and minus VOC. How you will calculate from the mesh analysis? Any circuit analysis method you can calculate open circuit voltage. That open circuit voltage is known as the VS. Now here this is how many number of meshes here? 1 and 2, and this mesh currents I1 and I2 in clockwise direction. If you apply here I1 equals to I2, because this open circuit current is 0, if you apply KCL, the same amount of current flows through 4 ohms resistor and 1 ohm resistor. That means I1 equals to I2. If you apply KVL in the mesh 1, 28 minus 4 I1 plus VOC equals to 0, and next that equals to V1 4 I1 plus VOC equals to 28, that is equation number 1, and second one I1 equals to I2, this one. Next 7 minus 7, 1 into I2 and plus VOC equals to 0. If you apply KVL in the mesh 2, and that equation equals to minus 1 I2 plus VOC equals to 2. This is equation number 1 and this is equation number 2. Solve these two equations, you will get VOC equals to 11.2 ohms. 11.2 ohms. Here we got VS we got, and VRL equals to determine RS equals to same, remove the load resistance from a given circuit. I am drawing the circuit here. So first here this is the circuit, given circuit 28 volts and 7 volts, 4 ohms, 1 ohm, and this is the RL. So first remove the load resistance from a given circuit, and this voltage source is replaced by short circuited, and this current source is replaced by, this voltage source is also replaced by short circuit. Calculate this open circuit terminal resistance. R equivalent between this open circuit uh, between open circuit terminals. Now this R equivalent is known as RS. Here 4 and 1 are connected in parallel, not in series. Now for that case 4 and 1 are connected in parallel. So in that case 4 into 1 divided by 4 plus 1, that equals to 0.8. This is 0.8 and this is 11.2. Now what about now according to the maximum power transfer theorem, when load resistance equals to source resistance, then maximum power transfer to the load. Now here RS equals to RL, that equals to 0.8. Here RL equals to 0.8. Maximum power transfer to the source to the load means here the maximum power is transferred, means this is 0.8. This is RS. RS we calculated from this following the steps, and RL equals to RS here. Then maximum power transfer to the load, that RL equals to 0.8. Now what about the maximum power formula? The maximum power formula equals to Vs square by 4RL. Here Vs square means 11.2 whole square divided by 4 into 0.8, that equals to 39.2 ohm watts. Now here next problem, what resistance should be connected across XY in the circuit such that maximum power developed across the load resistance? What is the amount of this maximum power? So see the circuit here across this X and Y terminals, So load resistance. Calculate this load resistance. Here P is the maximum in the question. So maximum power developed across the load resistance. So now if you convert from the circuit into the Thevenin equivalent circuit, first Vs and Rs, and this is RL. Now first calculate the Rs, then you will get the RL value. After that, after calculating Vs and the value is a maximum amount of power. So the maximum amount of power we can calculate it from the Vs and RL. Now here Vs calculation, here first draw the circuit. This is 10, 40 volts, 5 ohms, RL 20 volts, 10 ohms and 10 volts, minus, plus, plus, minus, plus, minus. Now remove the load resistance from a given circuit and calculate the open circuit voltage VOC. Now here how many number of meshes? Here 1 and mesh 2, and mesh 1 current is I1 and mesh 2 current is I2. I1 equals to I2 in clockwise direction. Here not I1 equals to I2. I2 current equals to 0 because it is a open circuit current. Now here if you apply KVL in the mesh 1, so 40 5 I1 and minus 10 I1 minus I2 and plus minus 20 equals to 0. Algebraic sum of total voltages in a loop equals to 0. Now here 15 I1 minus 10 I2 is equals to 20, that is equation number 1. And next minus 10 I2 minus I1, and next this 2 are not this 2 I2, this is 0, there is no 2 I2, and plus VOC equals to 0. There is no 2 ohms resistive drop here. Now here if you solve this two equation, is the simplified equation, this is 0 and 10 I1 and plus VOC equals to 0, equation number 2. If you solve these two equations, you will get this is 10, sorry. Now here I1 equals to 1.33 and VOC equals to 23.33. Now if you saw we have this is Vs. Now here from this Vs RS value, so now here remove the load resistance from a given circuit. This one 40 volts and 5 ohms, this one, and this is R1 and 10 volts and 10 ohms. And first remove the load resistance from a given circuit. Voltage source is replaced by short circuited. This voltage source is also replaced by short circuited, and this voltage source is also replaced by short circuited. Now here this 5 and 10 are connected in parallel. Now here 5 and 10 are connected in parallel. The simplification is 5 into 10 divided by 5 plus 10, that equals to 3.33, and this is 23.33. From this here, the resistance should be connected across the XY terminals such that maximum power transfer to the load. That means RL equals to RS according to the maximum power transfer theorem statement, 3.33. And next, ohms. Then here maximum P power is the maximum, so this value is 3.33, and this value is, that resistance is 3.33 ohms. Now what is the maximum power? P maximum equals to Vs square by 4 RL. So Vs square equals to Ps equals to Vs square by 4 RL equals to Vs equals to 23.33 and divided by whole square upon and 4 into 3.33, that equals to 40.86. This maximum amount of power equals to 40.86 watts. Next problem. What would be the value of RL such that maximum power can takes place from the rest of the network to RL? Obtain the amount of this power. Now here see the circuit. Here two voltage sources are given in the network, 2 volts and 4 volts, and 2, 12, 1 and RL and 3 ohms. So find out this RL when maximum power transfer to the load, and calculate the maximum power also. This first question, and in each question there are two questions, RL value determination and P maximum determination. First RL value calculate, and then Vs also calculate, then only we can calculate the Vs square by 4 RL. So from this you can determine, we need the RL and Vs, Rs and Vs. So this circuit is replaced by Vs and Rs and connected across the Vs and Rs are connected in series, and that whole circuit is connected across the load terminals. Now here, to determine the determination of Vs, first remove the load resistance from a given circuit and calculate the open circuit voltage. That open circuit voltage is known as the Vs. Now I am drawing the circuit. This is the circuit. Two volt, 2 ohms, 1 ohm, 3 ohm and 4 volts, and this is 12 ohms, and this is RL. So first remove the load resistance from a given circuit, calculate this open circuit voltage VOC first. Now here using mesh analysis method you can calculate the RL value. Now you can calculate the VOC, that VOC is known as the Vs. This is Vs. So possible number of meshes in a given network, 1, 2 and 3 here. Now mesh 1 current is I1 in clockwise direction, and mesh 2 current is I2 in clockwise direction, and mesh 3 current is in clockwise direction. Now here I2 equals to I3 because this branch current is 0 because it is an open circuit. Now if you apply KVL in the mesh 1, now 2 into 2 is equal to 2 into I1, 2 minus I1 and 2 minus 2I1 minus 12I2 equals I1 minus I2 equals to 0. And second equation, that simplified equation of this one, 14, 2 plus 12 is 14 and minus 12I2 equals to 0. This is I1. Now this is equation number 1, is equal side, RHS side 2. Now the second equation, if you apply KVL in the mesh 2, that equals to minus 12 I2 minus I1, next 1 into I2 minus VOC equals to 0. The simplified equation, minus 12 I1 plus 12 plus 1, that is I2 equal 13 I2 equals to minus VOC. Now here third mesh equation, VOC plus VOC and minus 3I3 and minus V4 minus 4 volts equals to 0. The solution for this, here I1 equals to minus 0.2 and I2 equals to minus 0.4 and VOC equals to 2.8. And here I1 equals to I2 indicates, that is I3 also minus 0.4 amperes. Now here find the RS value. Find out the RS value means RS equals to same. Remove the load resistance from a given circuit first. Now this is the resistance 2, 1, 3 and 12, 2 and 4 volts. Now remove the load resistance from a given circuit. Voltage sources are replaced by short circuit and current sources are replaced by open circuit. This is also voltage source, and calculate this R equivalent, and this R equivalent is known as the RS, that is Thevenin's equivalent resistance. Here 2 and 12 are connected in parallel, again in series with 1 and again in parallel with 3. Now see here 2 and 12 are connected in parallel and in series with this one, and 3 is again connected in parallel. This is the scenario. If you simplify this one, and that is 1.43. This is 1.43 ohms and this is 2.8 volts. VOC equals to 2.8, that equals to Vs. Now here, according to the maximum power, what should be the value of RL such that maximum power can take place from the rest of the network to the RL. Now here, when RL equals to RS, then maximum power transfer to the load. Here RL equals to RS, that equals to 1.43. This RL equals to 1.43 ohms here. Now what is the maximum power? So obtain the amount of this maximum power. This maximum power, that equals to Vs square by 4RL, that equals to Vs square by 4RL, that equals to Vs equals to 2.8 whole square upon 4 into that 1.43, that equals to 1.37. This maximum power equals to 1.37 watts. 1.37 watts. Now last problem, discover the highest power, that means maximum power that can be transmitted to the load resistance RL of below circuit. Now here this is the circuit, in that one current source and one voltage source is present, and this is the RL. Here this RL you need to determine 5, 20 and 3 ohms resistor. How you will calculate this RL and maximum power delivered? That maximum power equals to Vs square by 4RL. Now this entire circuit is replaced by this RL. This circuit is replaced by entire RL. The circuit consists of single voltage source in series with the RS single resistance and connected across the load terminals. Now here Vs calculation and RS calculation. By getting Vs and RS, we can calculate the RL according to the maximum power transfer theorem and maximum power value. Now here Vs calculation, here first draw the circuit for the Vs calculation. Now remove this load resistance and calculate the open circuit voltage. That open circuit voltage is known as the VOC, that means Vs. VOC means, that means Vs. This is 10 amp, 5, 20 and 30 and 100 volts. Now here possible number of meshes 1, 2 and 3, and mesh 1 current is I1 in clockwise direction, and mesh 2 current is in clockwise direction, and mesh 3 current is in clockwise direction. Now I2 equals to 0 because it is second branch current. This load is removed here. Now, if you remove the load, that means open circuit, that open circuit current is 0. Here I2 current equals to 0. Now, if you apply KVL in the mesh 1, we cannot apply a KVL for the mesh 1 because this current source value is the I1. Directly you can take I1 value equals 10 because this loop current, this mesh current and this current source direction is in same direction from bottom to top. Then you can take plus sign. So 10 amperes directly you can take I1 equals to 10. Now here second mesh equation, if you apply KVL, 5 into I2 minus I1 and 20 into I2 minus I3 and minus VOC. Now here I2 equals to 0. So I2 equals to, so 5 plus 20 is 25 and minus 5 I1 minus 20 I3 is equals to minus VOC. Now here equation number 1 and equation number 2. 20 I3 minus I2 and 30 I3 and 100 equals to 0 in the third mesh. And if you solve this, so 0 I1 minus 20 I2 plus 50 I3 is equal to minus 100. Equation number 1, 2, 3. If you solve these three equations, you will get I1 equals to 10 and I2 equals to 0. I1 equals to 10. I2 equals to 0. That is open circuit. I1 equals to this current source value and I3 equals to this 2 minus 2 amperes and VOC equals to 10 volts. Now we have this is 10 volts and calculation of RS. So now here RS value over here. So now here I am drawing the circuit here. I am drawing the circuit for this current source. This is, and next this is the resistance. This is the resistance 5 ohms, 20 ohms, 30 ohms, and this is 100 volts. This is the RL and this is closed short circuit. First remove what are the steps to calculate the RS value. So now remove the load resistance from a given circuit. Voltage source is replaced by short circuit and current source is replaced by open circuit. Now here these two are connected in series and again in series with the 5. 20 and 30 are connected in series and 5 ohms is connected in parallel and 5 ohms is connected in series. 20 and 30 are connected in parallel and again in series with the 5. The simplified value is 17. This is RS value is 17. Now here we got the 10 volts, 17 ohms and RL equals to, this RL equals to, when RL equals to RS at maximum power condition, highest power that can be transferred to the load, and this RL equals to 17 ohms, that equals to 17 ohms, and this maximum power formula that equals to Vs square by 4 RL, that equals to Vs square equals to, now 10 square by 4 into this RL equals to 17. Now that equals to 100 by 4 into 17, that equals to 1.47. So 1.47 maximum power, that maximum power. So discover the highest power. So that highest power is the 1.47 watts. I hope all these problems are clear to you and the derivation of that maximum power condition and maximum power formula and statement. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.